Hello everyone. So today is a snowing day. So we use lecture video instead of in-person class. So we just had our second exam. So I will return your exam this Thursday. Okay. So also you can find your scores for this exam on Blackboard. Okay. So far we have exam 1, exam 2, right? Okay, so let's say we have exam 1, exam 2. So exam 1 is about the polynomial function. Exam 2 is about exponential function or log function, right? So now we move to those function. So those we call those trigonometry function. Okay, so we say in pre-calculus, the main issue is function. So we will discuss those functions, right? So far we discussed polynomial functions and exponential functions. So now we move to trigonometric function. So this word trigonometry, this is just combined trigonometry. Okay, so the trig means three. So okay, trig. Trig means three or like let's say this triple, right? We know this word triple. Tri means three. So trig means triangle. Metric means measure. So trigonometry means measure triangles or measurement about triangles. So those trigonometry functions just come from those triangle. Okay, so we have those triangle like this triangle. Okay, and this is a triangle. Just triangle is three sides, and we have thus like for any triangle. This three angle together, three angle together. Suppose I put angle A, this A, B, C. We have thus, right? Angle A plus angle B plus angle C equal 180 degree. Okay, so I'm sure you will never forget this, right? So we have many triangles. So we just start from simplest triangle. So those simplest triangle is a right triangle. So right triangle is like those angle, right? We have one angle is right, so can be like this right triangle. So we denote this right angle. We use this notation. Or can be this, right? Okay, so this right angle. So for right triangle, we have three sides of three angles ABC or vertex ABC. So we use uppercase. So denote angle or vertex ABC. So we can call this angle as angle B, or we use angle theta. So from these three angles, so from the three sides, we can produce 6 ratios. Like let's say like we have ABC, right? The three sides. B. So here we use standard notation for triangle. If this is A, B, C, then we denote this side face this angle A is or vertex A is this side is A, this side is B, and this side is C. So we use uppercase for vertex or uppercase for angle, but the lowercase for sides. So we have A, B, C, 3 sides. So we can produce those ratios. Let's say like A over B, A over C, right? Or B over A, or B over C, right? So for C, or C over A, or C over B, right? So we can produce those 6 ratios. So we give those 6 ratios a name. So we call those ratio as sine for this angle, and this ratio cosine. So we have sine, cosine, tangent, cotangent, secant, cosecant. Okay, so which ratio is sine, which ratio is cosine? So we define this. We say like a sine of this ratio B over C is sine. So we just remember this way. Our sine, this angle sine is opposite side. We call this for this angle, this side is opposite side, and opposite side, and this we call this a hypotenuse. So opposite side over hypotenuse. This is sine, and this is cosine is A over C. This is cosine. So cosine is adjacent, like this side adjacent over hypotenuse, right? And the tangent is B over A. Okay. So those are just the 6 ratios of 6. So we call the 6 trigonometric functions: sine, cosine, tangent, cotangent, or secant, cosecant. So it's hard for us to remember all this sine, this cosine, this tangent, right? So let's say, so we say like so we have 6 of them, but the most important are sine, cosine, tangent, because we can write others like cotangent. A over B is 1 over let's say this equal 1 over B over A, right? So we use as cotangent will equal 1 over tangent. Okay. And secant, I just remember the secant. I just remember this will equal 1 over cosine. Okay. And the cosecant, so we denote as cosecant equal 1 over sine. So I just remember like if this is, so this is 1 over C, like A secant 1 over cosine, C cosecant 1 over sine. So here among the 6 of those, 6 of them, so mostly are sine, cosine, and tangent. So our calculate just to give us those 3, because other 3 can be written as a reciprocal for others, like cotangent is 1 over tangent, right? Cosecant 1 over cosine, cosecant 1 over sine. Okay. Okay. So for a right triangle, if this angle is fixed, then this ratio is fixed. Okay. Let's say. Okay. So if this angle is fixed, then those ratio, like let's say this is A over B, so this ratio is fixed. If we just go back, so A over B, so this ratio is always fixed, right? So this means if we have the angle, then we can find the value for this ratio, or value of sine, cosine, and tangent. So now we have those kind of problem, like find the value for those things, like sine 23.4 degrees, or cosine this angle or tangent this angle. So for those kind of problem, we just use our calculate. Okay, so in our calculate, we should find sine 23.4 degrees is this. So the 39714 just like that. So if you get a different answer, then this means like this 23.4. You need to tell you calculate. This is degree. Okay, but in calculate, how can we calculate this degree? So we should check a model. Okay, so you check a model, then actually the measure angle, we have two ways, two systems. One is degree, one is radian. So you need to check a model and check this. So make sure that then you just tell you calculate. We use degree, right? So that you calculate know those 23.4 is a degree. So it should give you the same answer, right? Okay. So check your calculator, find sine button, cosine button, and tangent button. So you can find this. So for others, like this is all cotangent 25 degree, or secant 43 degree, or cosecant this. So for such a problem, we just changing this to, so in our calculator we do not have them. So we have to change this. What is like cotangent? We should change the 1 over tangent. So in our calculator, we have a tangent button. So we can find this, right? So secant equal, so we say this equal 1 over, so cosine, right? Is, so C, so cosine 43 degree. And the cosecant, so we should use this way, 1 over sine 32 degree. Okay. So use calculate, we can find those trigonometric functions value easy, right? Okay. Just to make sure those like this we use degree. So the two we should tell calculate like this. So those numbers is degree. Okay. Okay, so we say use calculate, we can find those trigonometric functions value easily. Okay, so but sometimes we can find those trigonometric functions value without using calculator for some typical situation. So let's check. So let's find for large triangle ABC. So there's 3 sides. Among these 3 sides ABC, we have this fundamental theorem. This theorem says like a square plus b square equals c square. So this relationship, this result, you should not forget, right? Yeah, a square, we just simply say a square plus b square equals c square. Okay, so use this relationship, we can find functions value without using calculate, or we can say we can find exact value. So the value from calculate is not exactly, right? Sometimes we just say approximation closely. Okay, so those So here for some, we say for some typical angle. So typical angle, we can find the exact value. So what are those typical angles? So those typical angles come from typical triangles. So let's check some typical triangle. So one is this large triangle, simplest large triangle. If these two sides are equal, like this side 1, this side 1, okay, and then this angle is 45 degrees, right? 45. So why is it 45? Because we say for large triangle, this angle plus this angle should be 90 degrees, so because this is already 90. So if these two sides are equal, then the two angles also should be equal. So half over 90, right? So 45 is a typical angle. And the other one is, let's say, is this. I'll put it to here. We say like we have those typical triangle. So we call it equilateral triangle, meaning these three sides are the same. So then these three angles are also same. So this angle should be 60 degrees, right? 60, 60, 60. Each angle is 60 degrees. So for this typical triangle, if we cut this into half, then we have this typical large triangle. So this is 60. Then this one is 30. Okay. So for typical angles, so we call those are typical angles: 45, 60, 30. So for those angles, we can find the exact value for its sine, cosine, or tangent, cotangent. So now let's check 45 degree. We check 45 this angle. So we okay. So if there's 45, then this side 1, we can this side other side. We call this a legs of this large triangle leg, right? We call. Okay, so if this one, that is 1, so what is C? This hypotenuse. So we just use this. Let me say a square plus b square equals c square, or c square equals a square plus b square. Okay. So we can plug in here. So what is A? A is 1. What is B? B is 1. So 1 squared is 1. So c square equals 2. So what is C? So C equals radical 2. So we can say like so this is 1, 1, then radical 2. Okay, so from here, so we can easily find what is sine 45 degree. So according to definition, sine, so is the opposite side 1, opposite side over hypotenuse, right? So equal 1 over radical 2. And what is the cosine? Cosine this angle equal, so adjacent, so that's also 1 over hypotenuse radical 2, right? And the tangent equal, so 1 over 1 equal 1. So tangent 45 degree equal 1, right? Okay, so once we have sine, cosine, tangent, then or cotangent, cosecant, or so we can easily find them. Okay, so we say sine 45 or cosine 45 degree is 1 over radical 2. So 1 over radical 2 is okay. But before we always say, we don't like a radical in denominator. We want to rationalize the denominator. So we also sometimes we prefer to changing that to multiply radical 2, right? So, okay, radical 2 over 2. So sine 45 radical 2 over 2. Okay. Okay. So this is the 45 degree. So how about 60 and 30? Okay. So we just assume those three sides equilateral triangles, three sides are 2, 2, 2. So we just cut it into half. So we have this large triangle. This side 1, like we just check, so this become 1, right? Cut it into half. So 1, and this side 2. Then we can find this side. Let's say we have such a problem like this is 1, this is 2. So what is this side B? Suppose this is B. What is B? So we just use this, right? We have a square, this side plus b square equal c square, or c is 2, yeah, equal 2 square. So from here, we find b square should equal 3, right? And then b equal radical 3. So we have this large triangle. This is the 1, this is the 2, radical 3. So let's say, so from this large triangle, so we can say 60 sine 60, this angle is cosine, and this angle is tangent. Okay, so sine equal opposite side of hypotenuse, so radical 3 over 2. Cosine, so adjacent 1 over 2, right? Tangent, radical 3 over 1. So radical 3 over 1 over 1, just radical 3. So 60 degree. Okay. And so how about 30 degree? 30 degrees, we just use this angle. Okay. So this angle is sine. So equal opposite side becomes thus, like 1 over 2. Right? So let's suppose that you stand here. So this angle is here. So its sine is opposite side over hypotenuse, 1 over 2. And the cosine is radical 3 over 2. And the tangent 30 degree is 1 over radical 3, right? Yeah. So 1 over radical 3. So sometimes we don't like radical in denominator. We can change this to radical 3 over 3. Okay. So this for those typical triangles, we can find exact value. Without using calculator, we can find those so exact value for trigonometric function. Okay. Okay, so now so we can say that those kind of problem we can regard those as solving large triangle problem. Okay, like suppose like for 45 degree we know this one, then we need to find this side, right? If this one, then this 45 degrees, then we find this hypotenuse, right? So such a problem, we call those kind of problem as solving large triangle problem. So for a large triangle, it seems we have 4 parameters. Like we have 2 angles, 3 sides, right? ABC. But these 3 sides, if we know 2 of them, we can find other 2. So let's see. So we have this. This is 90-degree fixed. Suppose this is A, B, C. This side A, this side B, this side C. So this angle, okay. And if we know this angle, then if we know angle B, angle A is easily found, right? So we just say we just have 3 sides A, B, C, and 1 angle. We can regard we have only 4 parameters. So those 4 parameters, we say if we know 2 of them, we can find the other 2. Okay? So such a problem is solving large triangle problem. So let's check those kind of problem. So we use graph to indicate this problem. Like for problem 1, we know this side is A is 8, B is 6. So we want to find C. Like this side is 6, this side 8, find C. So we just use A squared plus B squared equals C squared. We can easily find this, right? Okay. So, and from problem B, this side A we don't know, but we know this side is 4, this side is 5. So how can find this side? How can find this side A? So we just use this like A squared. Let's say we just use this A squared plus B squared. So here B is 4 equal C squared. C is 5, right? So we can find A squared equal 5 squared 25 minus 4 squared. 4 squared is 16, right? So equal 9. Okay, so we find A equals 3. Okay. Okay, so like problem 3 or 1, 2, 3 quite the same. We just use A squared plus B squared equals C squared. So for problem 4, we know this side is 3. We know this hypotenuse is 4. We want to find side A and this angle theta. We need to find 2 of them. So find this A, I think it's easy, right? We just use A squared plus B squared equals C squared. Okay, so what is A? So we find A squared equal, so 4 squared 16, right? So minus 3 squared 9. So this equals 7, right? Okay, so we say A equal radical 7. Okay, so find side A is easy. Then how can find the angle theta? Okay, so if we have these 2 sides, then we have this ratio. This is 3, 4. So this ratio 3, 4 is this angle sine. So we have such a problem. We know this angle's sine value equal 3 over 4, right? Sine equals 3 over 4. So we want to find the angle. So this angle, how can I find this angle? Angle theta. So we need to calculate. So here, so we need to use calculate this button, sine minus 1 inverse. So we just just the sine minus 1. We just multiply sine minus 1. Oh, but we all divide by sine, just apply sine minus 1. So angle theta equals sine minus 1, 3/4. So check our calculate. We have this button, sine minus 1 button. So inverse, we say, okay. So from this button, we find, let's say, use the sine theta equals sine minus 1. Or 3/4 is just 0.75. So if you keep 3/4, doesn't matter. So just check this sine minus 1 button. Okay, sine minus 1, then put these numbers, 3/4 or 0.75. So we find this angle equal 64.5. So this 64.5 is degree. Okay, degree. Okay, so those kind of problems is like solving right triangle problem. So if you give me 2, we can find others. If you give me 2 sides, like problem 4, give me 2 sides, we can find other side, and also find this angles, or this angle, or use this angle, right? We can find those angles. Okay. So as application for solving right triangle, we have many applications. A typical application is just like find a height of building, find the height of a tree, like that, right? So let's say like here we want to find, let's say here we have a tower or very tall. Okay, so we cannot measure this tall directly. So how can we find the height of the building? So usual way is we just from the base point pick a point, then we find, okay, I'm sorry, find this angle. So suppose this angle is 89 degree, or this almost 90 degree, and we can find this distance is 25.9 feet. Okay, so then we want to find this h. So we just regard this as a right triangle, right? So we say h is h over, we just say h over 25.9. This equals this angle's tangent, right? So this equals tangent 89 degree. So use our calculate, we can find tangent 89. And this number is quite big, so then h equal tangent 89 multiply 25.9. We can find this. So yeah, so just use this, like 25.9 multiply this, so we get this. Oh, this building has a 1,483 feet. Okay. So for this problem, like we want to find the height of the tree. Okay. So we want to find this height of the tree. So one thing that we can measure this distance. Oh, here we know this. Like we say, oh, this like some people just play kite. A kite is calculate in the top branch of tree. So we know the length for the kite string. So this is 90 feet, and we can measure this angle 22 degrees. So we regard this is just a large triangle, right? So we can say, oh, we want to find the h. So we say h over 90. So this time, this ratio is this 22. This angle's sine, right? This ratio is sine. We say this equals sine 22 degrees. So use our calculate, we can easily find sine 22 degrees and multiply 90. So this is the height of a tree, right? Okay. So those typical problem for application for large triangle, right? We want to find the height of a tree or height of the building. Just use this way. So now let's check this problem. We want to find the height of a mountain. So let's say this is a mountain, so we want to find the height of this mountain. So for a mountain, so we cannot go to the base of a mountain, right? So let's say, so our way is just like that. We just pick 2 points from other side of the mountain, like from this point A. We measure this angle. Oh, this angle is 42. Then pick another point. Find this angle of the mountain. We call this angle the angle of elevation. So this angle is 35 degrees. And we can easily measure the distance between those 2 points. So the 2 points is 0.5 kilometers. Okay? So based on those information, we want to find the height of the mountain. So here, we regard this, we have 2 large triangles, ABC and DBC. We have 2 large triangles, ABC, DBC. Okay? Okay, so we okay. So we let's say we know D. There's a distance from D to A. We know DA, but we don't know AB. So we assume AB. This distance is X. So we don't know X, don't know H. Right? I'm sorry. This is X. Okay. So we want to solve the equation. We want to find H and X. X we don't know, but there's X. We don't need to find this X, right? Okay, but anyway, here we want to get some information. Let's say, so we apply. We say H over X. We just check this large triangle ABC. So we have thus. We say X over H. No, not X over H. H over X. Yeah, I got confused. Yeah, H. This doesn't matter. Actually, H over X is tangent. Tangent 42, right? So we say we can use H over X or this ratio or X over H. The same doesn't matter. But we prefer like a sine, cosine, tangent. And so we know for tangent, 42 tangent is H over x, right? H over x means this, like h over x is tangent. And the same way, this h over this. So from right triangle DBC, we have h over, so db is equal dA, so this equals 0.5 plus x, right? So equal tangent 35 degrees. So here we have two equations. One is this, and the other one is h over x equal tangent 42 degrees. So this is tangent 35, tangent 42 is some numbers, right? Is some numbers. So from calculate, we find those numbers. Then we can, let's say we want to solve for x. So we don't need this. We want to solve for h. Yeah. So we don't need this x. So we just replace the x. We say, what is x? So x equal h over tangent 42 degrees, right? X equals this. So we just put this x into the first equation. We call this equation 1. So we get this. Okay. We get the plug into equation 1. We get this. So but to here, h over 0.5 plus this x h over tangent 42 equal tangent 35 degrees. Okay, so from here, so we can solve for h. Okay, so this is the question. So how to solve this? Oh, this we have denominator, so we don't like denominator. So this is just we use a little bit of algebra, right? So usually we multiply denominator, we get the letter with the denominator, so we get this. So here, so multiply both sides, multiply this 0.5 plus this, so we get that h equal, here multiply the denominator, right? Equal tangent 35 multiply 0.5 plus h over tangent 42 degrees. Okay. So this tangent 35, tangent 42, those are just numbers. So this equation just become linear equation. Maybe we can put this like so: h equal 0.5 times tangent 35, so plus h times tangent 35 over tangent 42. So just as we have such an equation, right? So regarding this, just the number, some number coefficient. So we put h together. H, so 1 minus like this tangent 35 tangent 42, so equals this, like 0.5 multiply tangent 35. Okay, then finally we get the h, right? Okay, so we solve this problem. Okay, so we see, so for this kind of problem, it seems a little bit tough because it involves two large triangles. So from the two large triangle, we use this ratio, that ratio, so we get two equations. So to solve those two equations, so we need some algebra. So such a problem looks a little bit tough. So we try find a better way to solve such a problem. Okay, so this will be our next class topic. Okay. Okay, so today's topic is large triangle trigonometry functions. So those trigonometry functions come from large triangle. So this ratio is sine, this ratio is cosine, and that ratio is tangent, sine, cosine, tangent. And for other three ratios, like cotangent, secant, cosecant, just equal 1 over those, right? Okay. So we say for general angle, we want to find those values, sine this angle, cosine this angle. We have to use calculate. But for some typical angles, like 45 degree, 30 degree, 60 degree, for those typical angles, we can find the exact value. We don't need to use calculate, because for three sides ABC, we have this formula, like a square plus b square equals c square. So from this relationship, so a square plus b square equals c square. So if you give me 2, we can find the other one. If you give me AB, we can find a C. If you give me AC, we can find a B, right? Okay, so such a problem is solving large triangle problem. So solving large triangle problem, we have many real world applications. The typical applications are find the height of mountain, or find the height of this building, find the height of this tree, like those kind of problem. Okay. Okay. So we find like so for like find those kind of problem, like find the height of mountain. So we have to involve two large triangles, right? So if we have two large triangles, then the relationship become more complicated. And so we need some algebra. We have two equations to solve those two equations. We need lots of algebra. So looks like not so easy. So next class we just try to find an easy way to solve those kind of problems. Okay. Okay, so there's today's class. So thank you for watching, and see you Thursday. Okay, so bye-bye.